All right, chapter 11-5 is polygons. Now, polygon is a very, 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 very generic term. Okay, so first we're going to define what a polygon is, kind of like we defined what quadrilaterals were. Does anybody remember, without flipping over to your other side, what were the three things that were required for it to be a quadrilateral?
4 angles.
Okay, hang on. That's 4 angles. What else? Hang on. Closed. And what's the other one? 4 angles, closed, 4 sides. Good. So for it to be a quadrilateral, it had to be a closed figure. It had to have 4 sides and 4 angles, exactly 4 sides and exactly 4 angles. Polygons are even more generic than that. Okay. So here's what is required for a polygon. Okay. It is a closed figure. Okay. That part's the same. At least, oops, 3 sides. Nope, that's for a quadrilateral. We're getting even, we're going backwards a little bit in classification here. At least 3 sides. And the sides have to be straight line segments. So basically nothing curved. If it has any kind of curved edge to it, it's not a polygon. And the last thing, and there's a very technical way to say this, it's that they must meet at only the end point, but basically it means no crisscrossing. Okay, so I'm going to put the kind of the easy wording of it. And what that means is, and you'll see it here in a second, but you can't have a shape that looks like this. Because it crisscrosses and intersects itself, that's what makes it not a polygon. Okay, so with that very, 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 very general definition, would a triangle be a polygon? 3 sides, straight sides. Okay, would a quadrilateral be a polygon? 4 sides, straight sides, closed figure. Huh?
Oh, at least it would have to be.
At least. It can have more than that. It can have 25 sides. It can have 8 sides, like a stop sign. It can have 5 sides. It can, but at least 3. Okay, make sense? So, like I said, polygon kind of goes backwards a little bit. So you've got polygon just means, poly means many. So you've got polygon, which is basically anything that's a closed side. And then under that would be your triangles. And we've learned how to classify triangles. What are some of the classifications for triangles? Somebody tell me some of the words that you would use to classify a triangle. Yeah, but the classification names. Isosceles, scalene, equilateral. There's another way. You can also do it by angles. Right? Obtuse, acute, straight. Nice. Okay, very good. All right, so quadrilaterals. Those would be a polygon, right? Because they're 4-sided closed figures. And we learned how to classify those. What are some classifications of special quadrilaterals? Remember, there was generic quadrilaterals and then special ones. What were some of the special ones? Blake?
Wait. Hold up. Like it's a hexagon? No, I don't know.
Rectangle? Sophia? Rhombus? Parallelogram, square, one more. Trapezoid, very nice. So we can classify triangles. We can classify quadrilaterals. And then there's even kind of a bigger classification of just polynomials in general. So that's what we're going to go to next. So I want you to reproduce this box here in just a second. I'll blow it up, but wait just a second. So this is just the wordy way of saying what I just said. Closed figure, 3 or more line segment sides, and then it says the segments that form the polygon intersect only at their end points. That's where it can't crisscross. So this was an example of not a polygon because of that crisscross. This would not be a polygon because of the round edge, and this would not be a polygon because it's not a closed figure. So if you have to describe why it's not a polygon, you don't have to get like super wordy or fancy, just curved edge, crisscrossed, or not a closed figure. Okay, those things would just disqualify them from being polygons. So polygon classifications are classified by the number of sides they have. We've already talked about triangles and quadrilaterals, but here are some more terminology that you'll need. So somewhere on your notes, and if you need to use a separate sheet of paper for this, that's totally fine. You can add it to your 11.5 notes. Just make sure you have this down. Okay, and I'll give you guys just a couple of minutes to reproduce this, or at least write the ones that you don't know.
I remember doing this last year.
Yeah, I believe you did. So every year it kind of builds on itself. So this year, now we're going to go a little bit further, and we're going to start finding the sum of all the angles inside of all these shapes. And it's a super easy equation. I got it. Need a minute. Okay, I still see some pencils. I'll wait. All right. Just FYI, just in case you're not done, or if you can't read your own writing or whatever, this little diagram is on Canvas. Let's see, pull up our Canvas really quickly and I'll show you. So pre-algebra, and then if we go to our home page and you click on 11.5, it's there. Okay, so if you need it. I also, for 11.4, like I told you I would, on 11.4, there's your quadrilateral classifications. Okay, so just in case you didn't get it in your notes, or can't read them, or for whatever reason you need it, it's there. Okay, let's see. So if we have some quadrilaterals, and you'll have these on your homework, okay, and you need to classify them, you just count the sides. It's really that simple, okay? And there's regular polygons and there's irregular polygons, and I don't know that. These are all examples of regular polygons, and the reason they're regular is because all their sides are congruent, okay? So non-regular ones would be an example of, I don't have it here, where's it at? Okay, this would be an example of a non-regular polygon, right? Nope, this one, sorry. Because they're not all congruent. So there's regular polygons and there's non-regular polygons. The only difference is that all of their sides are congruent, and that'll come into play here in a minute when we go to do something else in our notes. Okay, so the first thing that we want to do is now on your homework, you're actually going to have some pictures. It's very simple. Just count the sides. That's all you have to do. There's not examples of that on these notes, but I think that's pretty easy to do. Is it a polygon? Yes or no? If yes, classify it based on the number of sides. Okay. So what the first thing we're really going to do here that takes an equation is we're going to find the sum of the measures of the interior angles of each polygon. Now that sounds kind of daunting, but I promise it's not. So there's a very easy equation we're going to use. And I just want to explain why the equation works. You do not need to write all of this down, okay? The reason this equation works, and we talked about this the other day, when you have a quadrilateral and you bisect it, right, corner to corner, you create two triangles, right? And so when we said, what's the interior angles have to add up to? Well, it was two triangles. So 2 times 180 gave us 360. And what I want you to notice here is that when you have a 4-sided figure, it creates 2 triangles. When you have a 5-sided figure, it creates 3. A 6-sided figure creates 4, and an 8-sided figure creates 6. So what do you notice? What's the, yes. Yeah, exactly. Every polygon will create 2 less triangles than it has sides. So, and we know that if we take this triangle, triangle 1 and triangle 2, and we multiply 180 by 2, we get 360. So if we wanted to find the sum of each one of these angles, it's a 5-sided, so we would take 3 times 180. And then that would give us the sum of all those angles. If we had a hexagon, it's 6-sided. So we would take 4 times 180 because it creates 4 triangles and so on. So the official equation that I want you to write down, okay, and I want you to circle a word in your notes here. It's important. Circle or highlight this right here. The sum of the measures. Okay, because there is going to be 2 different things you're going to have to do in your homework. The equation for the sum of the measures is what we just talked about. It's the number of sides, and that's what N stands for. The number of sides minus 2 times 180. And that equals the sum of the measures of all the interior angles. Okay. And we've already shown that works on a quadrilateral, and we already knew that, right? A quadrilateral makes 2 triangles. 2 times 180 is 360. How about a heptagon? How many sides, based on your little graph that you have there, how many sides are in a heptagon? 7. So our equation would be 7 minus 2 times 180. So in your calculators really quickly, and you don't even have to, punch in 7 minus 2. You can just put 5 times 180 equals what? 900 degrees. So a heptagon, if you add up all the angles, you would get 900 degrees. Just like on a quadrilateral, if you add up all the angles, you get 360. If you add up all the angles on a triangle, you get 180. Okay, if you add up all the angles on a heptagon, you get 900. How about now, this is kind of interesting, and I want to point this out because I could technically write heptagon as 7-gon. Now you're probably not going to see it like that, but if you do, it's just a different way to write heptagon. 1 through 10 have special names. You saw that in that box: triangle, quadrilateral, hexagon, heptagon, all of those. So 1 through 10 have special names. After 10, they don't get a special name. So you'll notice 25-gon just means a 25-sided figure. Okay, so you would take 25 minus 2 times 180. And notice in the parentheses, you do the subtraction first and then you multiply times 180. So 23 times 180 is what? Good, 4,140. And don't forget your degrees, because we are talking about the measurement of interior angles. So you do want to put that degree sign. All right, pretty easy there. I don't think we need to do a ton of examples with that. I think that's pretty simple. It doesn't matter, like if it's a named one, it just means it's 1 through 10. So decagon, pentagon, hexagon, those are just those 1 through 10 ones. Like I said, the bigger ones, 100-gon, 12-gon, okay. All right, so this is where the term regular comes in. And remember I said regular. And the reason that you need to know that it's regular is because if something is regular, that means every angle is the same. So a quadrilateral, I shouldn't say that, a rectangle would be regular, right? Because all the angles are 90 degrees. And so if you know that And I don't, yeah, let's do quadrilateral here, a regular quadrilateral. Regular means that all the angles are the same. So if I know, and I'm gonna do the math here, even though we don't need to, if I know that a quadrilateral is 4 sides, so 4 minus 2 times 180, we already know that that's 360, right? That the angles of a quadrilateral have to equal 360. But let's look at these directions a little bit. Notice it says, and this is what I want you to circle or highlight because it's different from what we just did. Find the measurement of an angle, which means what? 1. So above the word an angle, it's 1 angle. So if all the angles add up to 360, how would we know what 1 angle equals? Could we divide it by the number of angles?
Yeah.
And that's where regular is important. If it's regular, they're all the same. And if they're all the same, we can just divide the total sum by the number of angles or by the number of sides, which is going to be the exact same thing. And we get 90, right? And we already know that each angle in a quadrilateral is 90 degrees, but that's the math that backs it up. Make sense? So out to the side here, just like we did at the find the sum, I'm going to give you the equation for find an angle or find 1 angle of a regular polygon. And that is the n minus 2 times 180. But then we divide it by n. We divide it by the number of sides. So it's just one extra step in the equation because we don't want to know the whole sum. We didn't want to know 360. We wanted to know if there's 4 angles and we know it equals 360 and they're all the same. We divide by 4 and we know each angle is 90. So when you're doing your homework, be mindful. If it says find the sum, then you just leave it as the big number. It's all of them added together. So 360. In a quadrilateral. If it wants to know an angle of a regular, it means it wants to know, you got to find the sum, but then you got to divide by the number of sides to get each individual angle's value. So let's try that on a nonagon. So how many sides does a nonagon have? 9. So we start out with 9 minus 2 times 180. What's that give us? Good. 1,260. That's for the entire nonagon. I just want to know 1 angle, so I'm going to divide by 9. I'm going to divide by the number of original sides, and I get 140. So the final answer for an angle or a single angle is 140 degrees. So that means if you were to draw a nonagon, a regular nonagon, meaning that all angles are congruent or the same, then each angle would add up to 140. How about a regular 12gon? We would do 12 minus 2 times 180. 1,800. And then because it's a 12-sided figure, we're going to divide by 12. Equals 150 what? Degrees. And I think I was looking at your homework. It looks like you get some decimals. So if we have a, let's see on your, I was looking at your homework, which ones gave you decimals? If you have a heptagon, how many sides are in a heptagon? 7?
Yeah.
7 in a hepta. So we take 5 times 180. And then we divide by 7, right? You get 128.5714,286, just round to the 10th. When in doubt, if the instructions don't say it, just kind of when in doubt, round to the 10th, because the key rounds to the 10th. So I'm fine with that. But just make sure you put your degrees. So if you end up with a decimal, so if you have like 128.6 degrees, that's totally fine, because you will have a couple of decimals on your homework. Okay. All right. Very last thing on your homework, and this is very easy. This is called a tessellation. That just means it's a repeating pattern. Really, the only thing we need to do with this is let's identify what polygons we can find in there. Okay. So I will tell you on this one, there is 4 different ones we should be able to identify. Can anybody tell me what one of them would be? Blake?
Heptagon,
Yeah, where's that at?
like 15.
Yeah, for number 15.
It's the
Is it hexagon, right? Hexagon is 6, right? So this one right here, 1, 2, 3, 4, 5, 6. So down here, we're gonna put that there is hexagons in here.
No, I'm talking about like the outside part. Like where.
Go point to the screen. Because these are kind of hard to say it.
Oh wait, I think I counted wrong. Wait, maybe. Wait. 2 sides.
There's several hexagons, right? And you only have to, whoops, you only have to identify one, but there's several in here. What other shapes do we have?
I kind of thought it triangle.
Okay, we got triangles. Did you want to go point to one? Do you see it?
Wait, it is. Like I was talking about. Yeah, right here.
Where?
It is.
1, 2, that's an octagon, isn't it? Count them.
1, 2, 3, 4, 5, 6, 7. What?
1, 2, 3, 4, 5, 6, 7, 8.
Oh, okay.
That's all right. It's easy to do, especially in a tessellation. It's very easy to do because it's almost like it plays tricks with your mind. All right. So we've identified that there are triangles in here. What else? There's 2 more. Well, you can't for sure say it's a rhombus because it doesn't have those little slash marks to say they're equal. So rather than saying rhombus, let's just call it a generic quadrilateral. Okay. And it kind of looks like it could be a rhombus, but if it was for sure a rhombus, it would have to have these. It would have to have those slash marks for sure saying it. So let's just kind of keep it generic since we don't know for sure. So we know there are quadrilaterals and there's one more. Where at? Point to it for me. Well, again, we don't have the lines. They're not parallel. So that would just be another quadrilateral. Kind of looks like it could be, but they had the top and the bottom would have to be parallel for that to be a trapezoid. And without any slash marks, guaranteeing that something is, yeah. One more. I think we've actually already talked about it. Yeah, we have our octagon. So you've got 1, 2, 3, 4, 5, 6, 7, 8. So we have octagons. I just totally put an O there. There we go. There we go.
Yeah, no, when I saw these pictures, I thought they were actually.
No. And there's some math equations you can use to like find all the different angles and stuff, but we're not tipping our toe into that today. We're just going to kind of keep it overhead generic today. Just get used to looking at tessellations and being able to identify what polygons are in them. Do you think you see another one? Oh. Mm-hmm. All right, and so every other shape we find in here falls under the category of hexagon, triangle, quadrilateral, octagon. So those are all that are in there. Okay, sound good? All right, for your homework, it's a little specific, but I want you to do all of 1 through 6, and I'll go over this again once everybody has them. I'm just doing it for the recording, and then I'll go over it when you have it in front of you. I want you to do all of 1 through 6. And then for 7 through 16, you only have to do odds, but if you'd like to do evens, I'll throw a couple bonus points your way. And this is the first grade in the grade book for the first 9 weeks. So if you get a couple bonus points, you'll be at like 102% right off the bat. So 1 through 6, all 7 through 16, odds only, evens are a few bonus points, and then do 17 and 18. And that's the tessellations where you're just listing. Be mindful to read the directions of each section, okay? Because you've got just classify them, which means quadrilateral, hexagon, pentagon, just count the sides and write the word. Then you've got find the sum, then you've got find an angle, and then you've got tessellations. All right, for those of you at home, if you have any questions, shoot me an email.